morning, everyone. My name is Dan Ott. I'm the marketing coordinator here at Kyocera SGS Precision Tools. Welcome to our Machining with Micro Tools webinar. Um, Without further ado, I'm going to hand you over to our presenter, Andy Greaves, and he's going to walk you through a bit of the micro machining world. Without further ado, here's Andy.
Thanks, Dan. Good morning, everybody. Good afternoon. I hope we're all well. As Dan mentioned, this presentation is going to kind of summarize our micro tools offering, what we can supply, how we can help you guys, a bit of the background behind some of the tool design, and the parameters that you use when using micro tools. So just move on to a quick introduction to myself. If anybody did see the earlier Titanium's presentation, I am the same person that did that. My name is Andy Greaves, as I mentioned. I am originally from Sheffield, England. I moved over to the States in 2017 to start working for Kyocera SGS. I spent the first 5 or so years working for our Tech Hub division down in Danville, Virginia. In March this year, I became the third applications engineer for Kyocera SGS, covering the entire East Coast. So everything on that map is my responsibility. I have 8 sales guys that I work directly with, which then work directly with integrators, distribution, and end users themselves. I am based in Richmond, Virginia. So up and down the East Coast fairly regularly. If you have a sales guy that you work with on the East Coast of the United States, I'm sure at some stage we'll cross paths. So I just want to give a bit of a quick introduction into our offering of micro tools. We have recently massively expanded our micro tool range, seriously expanded our micro tool range. And this was through kind of an integration with Kyocera Precision Tools, which is not to be confused with Kyocera SGS Precision Tools. They had their own offerings and we had ours, and we kind of did a merger at the start of 2020. So at the beginning of 2020, we had around 1,000 micro end mill options and around 500 micro drill options. So in 2020, we increased our end mills offering by 360%. And our drills offering by 215%. So we've massively increased what options we have available for our customers. And that means we have extended lengths, we have through coolant drills, we have different flute counts, square, ball nose, corner radius options, and we're gonna cover some of these in more detail as we progress through this presentation. All of these tools are useful in pretty much every material that you can come across. There are some kind of niche applications in there where we have to get a bit more creative, but there's definitely a tool in our range now that that can be tailored to your needs. So as I said, we've gone from around 1,500 items to well over 6,000 items. And that was during the pandemic year as well. So as places were slowing down, we were actually increasing our range through like I said, the integration with Kyocera Precision Tools and our internal development as well that gets carried out in Ohio at our headquarters. So we'll just do a bit of an overview, looking a bit more in depth at what we've got on the table, and this doesn't include any sizes, but we'll cover some of them shortly. So we've got, this page just shows us 2 and 3 flute options. So we've got pretty much square, corner radius, and ball nose options for both flute counts, including 1.5 times D, 3 times D, and with the 3 flute options, 5 times D, up to 12 times D with the ball nose end mills. We've also then got extended reach items on both of those, so you can pretty much tailor everything to what you need. There's a couple of examples of some varying tools there on the right, showing the extended length or the ball nose profile with the longer cut depth. And moving on to the 4-flute options, pretty much same again as to the 3-flute options, but obviously you've got the extra flute in there, so you've got extra metal removal rate achievable by your feeds and your parameters that you're going to use. The overall reach, the long reach items are really useful. We found a lot of demand for those because just getting into these tight, intricate areas on these generally extremely small components is giving us that little edge over some competition to get in there and achieve the profiles and the geometries that you need from your final component. There's a bit more background as a bit of a tangent. My background is predominantly aerospace, so I am used to using a nice 3/4-inch end mill and piling through some titanium quite happily. So this micro world is pretty new to me, but it's something I've been picking up as the East Coast applications guy. And there's plenty of engineers and sales guys in our staffing that have the experience that'll fill in any gaps that come up. And if there's a very niche application in a very specific material, we've got someone there to fill in any gaps that any one of us may have. So going back to the drills, some of the drills we've got in our micro range are excellent, especially the internal coolant option. We'll go into that in a bit more detail shortly, but we have internal coolant drills down to sub half millimeter diameter, and they are excellent. They perform really well. They generally don't need to be babied quite as much as some of the external coolant items that we have, but again, it all depends on the application and what you need from the tool and what material you're cutting in. So there are all the options that we have as an overview. As I mentioned, we extended our product line. So we've included all these different items here, from new diameter micro drills, new 3-flute end mills, and then additional 2, 3, and 4-flute micro end mills with a corner radius. So the range, as I said, in end mills is up 300+%. We've pretty much got any size fits all to suit any need and any application specifically. Then from within that, we've expanded our range of 2-flute, 3-flute, and 4-flute uncoated micro end mills, but we've also added additional coated end mills within that, and we're going to discuss some of the coatings shortly within this presentation. Before this just becomes all series specific, I just wanted to go over a bit of background into the tool design and how these tools actually perform the cutting action that everybody requires from them. As you all know, your different materials require different helix angles and different shearing actions because of the properties of the material. So you can have a really low helix angle, which gives you great cutting action, but it reduces the rigidity. Some of the lower helix tools, so for example, some of the end mills are great for the aluminum applications, but we don't actually have aluminum specific micro tools like we do in our standard or high performance range above 2 millimeters, for example. Here, obviously, when you're working with these such small tools, you've got a lot less material to apply complex geometry to. But we have got in there as much detail as we can when it comes to the helix angle, the rake angles, and the other geometries that make up a performing tool. So as it mentions, just that last point, the degree of the helix angle will determine the rate at which the chips are evacuated. So you've got a really tight helix, you're going to get lots of cutting, but you're going to get slow evacuation of chips. And with these micro tools, you really need to be cognizant of getting those chips out of there. As small as they are, the room available for them is obviously very, very minimal, which can lead to chip clogging and therefore tool failure. The next one, as I just mentioned, is rake angles. So this really is where the cut actually gets in into the material and digs out that material, and how much force is then moved into the tool. So here it really affects how the tool performs overall, including the temperature generated. And obviously, the higher the temperatures that are generated in cutting, the sooner that you get that breakdown of the carbide substrate. So we have coatings on our tools that help protect that internal carbide substrate from the heat, and we also use the rake angles to help reduce that temperature while maintaining a good edge strength. So you have a positive rake angle, and you get less strength, but you can go more aggressive. You have a lower or negative clearance angle. You get that increased strength, but you can't go as aggressive. So there's it's a payoff in choosing the right type of geometry for tools, and each tool is kind of manufactured to suit a range of applications with, as I mentioned earlier, some specific niches within there. So, excuse me. The last point I'll make about the tool geometry themselves is the number of flutes. Now, I would assume that everybody in this webinar has an idea of material removal and machining in general, but very basically, the fewer the flutes you have, the bigger the chip you can make, because you got that more room in there. And then the higher the flute count, the smaller your chips are, but the faster you can make. So it's really dependent on how you're using these tools. A 2-flute tool or a 3-flute tool is great for roughing. A 4-flute tool in micro tools is generally considered better for finishing, because you can use a high-speed machining to get those chips made and out of the way, while maintaining a good level of performance. So what I wanted to do now is just cover a couple of our ranges of tools, and basically the range within them, how they can be used. As I mentioned, that pretty much all these tools, excuse me, are suitable for a wide range of materials. So this is a spotting drill. It can come Dynamite A coated or uncoated. Sometimes you don't need that coating. Depends on your application, how aggressive you are. The coating will increase your tool life if you're going more aggressively. It'll help reduce that thermal heat getting into your carbide, as I mentioned. It'll also help with the chip evacuation, because you've got that lower coefficient of friction, and you've got all the other positive attributes that come with the coating that we'll discuss within this presentation later. All of our micro tools are produced from a special grade of carbide, which is sub-micron grade of carbide. It's across the board. Not everybody does have that, but as is, it's a special carbide grade that we use. All of our tools are manufactured to ISO 9001 quality standards as well. And Kyocera SGS are one of the very few manufacturers that actually reject more carbide substrate blanks that come into our facility than accept. We have in-house inspection capability where we will look at the chemical composition and the grain size of the base carbide material, and if we find any variation from its specification, we will return it. And we only accept the highest quality of carbide blank. So going back to this this tool in general, depending on its size, it can come with a 90-degree or a 130-degree point angle. It's just made for putting a spot in there, pre-drilling it, to help guide your next drill into position. We've got it in inch and metric diameters from the values you see there, from 0.005 to 0.125, which is the M080 range is your imperial range. That's on a 1/8 inch shank. And then you've got metric diameters from 0.15 mil to 3 mil diameter, and again that's on a 3 mil shank. So within that, you've got a wide range of tools in there that you can use just for spotting, just to pre-drill, get your hole point nice, ready to bring in your drill and quickly pop some holes in whatever it is you're machining. Again, suitable for a wide range of materials. The M105 series is one of our bigger ranges of micro drills. Again, it can come coated or uncoated, and it comes in times 10D or 17 times D length of cut. So you can pretty long lengths of cut for your micro tools. It's got a one. Oh, there was a bit of edit. Oh, sorry, apologies. Depending on the diameter that you pick will depend on the point angle at the end. So under 0.3 millimeters, you've got a 118-degree point, and above that, you've got a 130-degree point angle on your drill. These diameters come from 0.004 inch to 125 inch on an 1/8 shank, and in metric, again, they're a bit smaller now from the spotting drill. We can go down to a 0.1 mil drill to a 3.15. Again, that's on an 1/8 shank as well, not a 3 mil shank. And we've got over 336 different options available for that drill as well. More drills, the M226 and the L226. So these are left and right hand cutting, depending on how you need to use them. Come in 8, 12, and 14 times D length of cut. Again, you've got that variable point angle. When you get above that certain size, we can go to that slightly different point angle to be a bit more aggressive. You've got a bit more stock there to really work that tool and be a bit more aggressive with it, as I mentioned. And these drills go even smaller than the other ones. So we go down to a 0.0016 inch diameter and a 0.04 millimeter diameter. And we have over 660 items of this drill as well, which is pretty impressive when we've got such a range of drills. There's not much in there that you can't get what you need. The M range is the right hand cutting. The L range is the left hand cutting as well. Now, the ones I really want to talk to you about today are our through coolant drills, these M814 series. These are actually a micro drill with a double margin design as well, which gives you 4 points of contact when drilling over a standard 2-point drill, a single margin drill. So what you get from that is you get a lot more truer hole. You get it's self driving in the fact that it keeps itself more straight and true. And you also get kind of a burnishing effect from them extra 2 margins contacting your part. So it kind of reams the surface as it goes down, but not to a reamer level. You just get a nicer surface finish using a double margin drill. As I mentioned, it's got through to coolant, and this is down to a 1 mil drill or a 0.04 drill in Imperial, up to a 4 mil or 0.1575 inch, and that's in 1 mil increments, 0.1 mil increments as well. We've got 60 catalog items of this drill, 8 and 12 times D. It's really excellent at just straight plunging. There's no need to peg. You don't need to spot drill. It self-centers itself. It's a fantastic drill where you need to do the deeper holes, or you need to really push production to a higher level of performance. That through coolant really helps evacuate the chips. And if you're also using normal coolant as well, you've got that dish design between the flutes to help get more coolant down there as well if required. So you've got plenty of options for getting coolant in and chips out, which obviously, as we know, helps improve your tool life and gives you better productivity. If you're changing your tools less, you're not having time off machine not cutting. These drills comes with our Tynamite CR coating, which is aluminium chromium nitride coating. It only comes on our micro tools, this coating. It can be between 1 and 4 microns in thickness, so you don't get much variation on your thickness, and it just depends solely really on what size end mill, what size drill, sorry, that is applied to. Excuse me. It's got a really good coefficient of friction of 0.35. So again, all helping in getting that swarf out of the flutes and up away out of the cutting area to risk that could risk jamming or premature tool failure. A couple of end mills now we're just going to cover. The M032. This is our 3-flute variable helix end mill. Not many micro tools come with variable helix design. As I mentioned earlier, you haven't got all that much material to work with. So adding complex geometry such as variable helix, variable pitch, variable spacing, it really becomes tricky when you're working on these smaller diameter tools. But with this M032 includes that variable helix. That variable helix helps reduce chatter generation by intermitting the amount of like force applied into the tool. As the cut moves up the helix, the cutting action changes, and you get that difference in harmonics, which helps prevent chatter from starting, which can then lead to poor surface finish or premature tool failure. This tool comes with our Tynamite A coating or our Tynamite CR coating. It really depends on the application specific, and that's something that you can talk to one of our applications guys about, such as myself or our sales guys. Generally speaking, you can make either work. You might have to tailor your parameters, but if it comes down to cost and really finely detailing and dialing in your cutting setup, it can make a difference. It just depends on how in depth you need to go about doing it. This tool comes in square and with corner radius options, and comes available in diameters from 0.0312 to 0.118. And there's 100 different types of this as well. So you can get any diameter in any square, and then there'll be several corner rads with that depending on its diameter. So a very useful, versatile tool. Great for roughing because you've got that variable helix in there. But it's also great for finishing. You can go a bit lighter with it. It can be a one-tool solution if you need to do some roughing and finishing. The M4M series tool is our 4-flute tool. Again, this has the variable helix, so you've got that stability and harmonic breakup for chatter suppression. 1.5 times D or 3 times D flute length. Again, square corner radius options, and in diameters from 0.1 millimeters to 3 millimeters in 0.1 millimeter increments. So there's over 100 different items there where you can really tailor what you need. If you need something that's, if you're just doing some profiling and some finishing, for example, you can get away with using a 3mm end mill. You've got that extra strength and rigidity from using over, say, a 2mm. But if you need to use a 2mm end mill for a multi-operation as a multi-operation tool, excuse me, you can use this tool for finishing in multiple different areas, and you've still got that geometry in there that's working in your favor to increase your productivity. And this is the last tool I want to talk about. I say tool, it's actually just a range of tools, our M2, 3, and 4 CR range. So these are 2, 3, and 4 flute end mills, 3 and 5 times, 1.5 and 3 times D flute length. Oh, I'm sorry, there's a formatting error on there. I mentioned that twice. This comes square or with corner radius options, and again, it comes from 0.1 mil to 3 mil diameters, or 0.04 to 0.12 inch diameters. And because of that, we've got over 350 different variations on that tool. So again, if you're doing some roughing, a 2-flute end mill to get in there, you've got that space for your chip evacuation. 4-flute end mill for finishing, or if you need kind of a middle ground, a 3-flute option is ideal to do some roughing and finishing. You just tailor your parameters for roughing and finishing depending on how you're doing it, and you'll get the most performance out of your tools. So in that, I mentioned the coatings. As I mentioned, for our coatings on our micro tools, we have 2 options. Tynamite A, which is also available in our high performance, normal, larger tools. It's a fantastic coating, but we also offer the Tynamite CR as well, which I mentioned. Tynamite A is an ALTIN coating, so they're actually quite similar between the ALTIN and the ALCRN coatings. They're very similar hardness, very similar coefficients of friction, and as I mentioned earlier, it's all about just tailoring which coating you use for your application. And as I mentioned earlier, there are times where you don't need a coating. If you're not really pushing that tools, you're not pressed for time. You don't need that increased level of performance. You don't need to be going at it 110%. Uncoated tools are ideal. They're a bit cheaper. You do get a lot of tool life. You can't generally run them as hard. But if you're not maxing out your tools anyway, you can balance it out and find a suitable uncoated tool within there. And as you know, or if you don't know, the idea of a coating is to as I mentioned earlier, provide that thermal protection to your base, which if it breaks down, becomes weak, you get cracks, you get chips, and your tool will fail very quickly. With the low coefficient of friction, you get that increased slickness, that lubricity, which helps evacuate your swarf as well. And the coatings are hard, generally over 3,500 Vickers, and that helps resist wear more than your carbide base material. So you get extra level of protection in your tool to help it run for longer. Now, parameters for end mills and drills when you're talking micro tools can go from anywhere from kind of like 5,000 RPM up to, in drills you can be running at 40,000 RPM, and in aluminum you can be going even faster as well. But it all just really depends on what spindle you have and what your machine capability is. Not everybody has access to a 40,000 RPM spindle, but a lot of people need to run some micro tools every now and then for a specific component that they're making. So it's all about just tailoring the application to what you need. And the image on the bottom right is just an example page out of one of our micro tool catalog pages. It gives you a general overall view of parameters, and this is for a drill, and it's just baseline parameters that will get you going. They're generally middle of the road, so you can push them harder or you can go a bit easier on them depending on what you want to do. And the materials listed are your general categories that we've got, and it pretty much covers everything you're going to come across. If there's something on there that isn't on the list, for example, platinum isn't on there, and we have a customer that does some platinum machining, we can work with you specifically on a material, and if I don't have the answer on a material, as I mentioned earlier, we have a wide network of people that have pretty much been there and done it, so we can get you an answer on, well, platinum machines like X, Y, and Z, so maybe try a balance between these parameters and and send you that, and we'll get started. And if you need some on-site support, that is also something we can offer for your parameters to dial them in. There's a general rule of thumb for our micro tools that you drop the feed by about 30% when using an uncoated tool. But again, that can be very application specific. It can also depend on how long you want your tool to last. If you're not really vying for the highest possible tool life, excuse me, and you don't want to go to the expense of buying a coated tool, but you want to still run those parameters, you'll be able to. Your tools just aren't going to last quite as long. They're not going to take that heat quite as well as a coated tool. One thing I do want to cover from our catalog in our micro tools is our feed multiplier chart. I've had a couple of people question me on this before, and I've actually had to figure it out myself previously. And this is for our end mills. So what you need to do is for some of our tools, you need to use this feed multiplier, and I'm just going to do a quick rundown over it. So for an example, we're going to use the 031 tool diameter tool, and we are going to be cutting a 1080 carbon steel, for example, doing a slot. So the first thing you need to do is it runs you down, but it's nice just to be shown through it. So RPM, use the speed from the Inchometric baseline chart. That's this guy here, 35,506 RPM. That's assuming you have 35,000 capability. But for this example, we're going to assume that. The next thing you need to do is from the baseline chart, find your inch per minute, which is in this case 9.57, and your feed multiplier, which in this case is 0.95. So what you need to do is your 9.57 inch per minute feed is now void. And what you need to do is you need to do 9.57 times, times 0.95, which becomes 9.0915. So that's now your feeds are running at. One thing you also need to take into consideration here is how deep and how much radial engagement you've got. Now, if you slot in, obviously, you've got 1 times your diameter of cut. And here, there's 2 different colored scales. So if you are under or equal to 0.0312 diameter, you need to use 0.07 as a multiplier, or if you're above 0.0312, you can use 0.17 as your multiplier. So again, 3.12 times 0.07, your AP is 0.0021. Now, that's our guideline. If you want to go deeper, by all means go deeper, but just vary your feed, vary your speed, go a bit easier on the tool, you know. Again, it's all a case of dialing it in and making it work for you. There's no reason why you can't go deeper. You just have to be a bit more gentle on your feed, so you're not bending the tool effectively as much as you would be going less axial. So that's just an overview of that. It can be a bit daunting the first time you look at it, but once you go through it, if you try and go through it the way I just showed, doing effectively a line at a time to give you your corrections, you'll be fine on any application to get you a starting set of parameters and a starting axial or radial depth of cut. And from there, you can get it on machine, you can listen to it, you can feel it, you can see your surface finish, and you can look at your tool and say, okay, well, as tool wear is good, as surface finish is good, but we want to go a bit deeper, or we want to go 10% faster. And that's when you can start playing around with your parameters and your depth of cut to get the most out of it, if that's what you feel you need to do. One thing I do want to share with you as well, I only have a couple of slides left, so I'm going to start looking into wrapping this up. One thing I do want to share with you is our case studies that we have on our website. So if you go to our website, which is kyocera-sgstool.com, go into resources and case studies. We have multiple case studies in there where we apply different tools to different materials, and we go up against competitors, or we go into a new setup, and we document our results and show improvements and show parameters and metal removal rates in there and cost savings in there that are real world applications, and these are growing all the time. So the ones I've just shown there, they're the more standard sized end mills. But the more work we do with companies and we share information, that library is going to carry on growing at case studies, and there'll be more and more micro tools in there as it develops. Another thing I just wanted to cover is our tool wizard. So this is SGS Tool Wizard. You can see the link there on the top left, and this is kind of a product finder, application specific calculator that allows you to input your requirements for a tool. So you can input the number of flutes you want and the flute length you want and the diameter you want. You can also include cutting data such as axial and radial depths and the material you're cutting. And what this calculator will do, it will narrow down suitable tools as applicable to your application. And then what it will also do is it will give you suggested parameters within that that then can also give you a baseline. So it's a great way if you just quickly need to find something, you don't want to go looking through a catalog, you can't get hold of your integrator, or you want to start in line to say, to call the SGS guy and say, look, I've been on your tool wizard, this is what I need to do, this is what I've put in. It's suggested end mill B, what do you think? And from that, it'll give you your tool number, and you can share that with the sales guy and the parameters, and we can look into it and say, well, how's it fixtured? What's the part like? How well is it set up? And we can turn around and say, yeah, that's the perfect tool. Or we can say, yeah, it's a great tool. Consider these other options as well. We've used tool C in this application before and it worked really well. So it's just a good baseline to get you going. It'll give you a part number and it'll tell you all your attributes to your tool, and it'll give you the parameters as well to start your programming and eventually your machine. My second to last slide is about our next webinar. I'm sure Chris will really appreciate me sharing his face with you all. So Chris Dixon is my West Coast counterpart. He's based at Fort Worth in Texas, and he has an area even bigger than mine. So he's often on the road visiting and working with his sales team. Some of you may have met Chris. He's a great guy. Plenty of experience in the industry. Very good at firearms industry work and steel work in general. He will be doing our next webinar, which is going to take place in October. Dan may have a better idea of the exact date and time. I'm sure he'll mention that after if it's been set yet. So that's going to cover tooling and methodology of required for cutting high temp alloys. So what we want to do with these webinars is keep giving you all information on not only our range of tools and what we can offer tooling wise, but also how to approach materials you may not have encountered before, or you may not have had a requirement to cut before. So far, you can check out any of our 3 earlier webinars. There's a link at the bottom of the slide there. You just go to our main website, again, click resources as you would for the case studies, but click webinars. There's 3 up there at the moment. There's one on steels, there's one on stainless steels, there's one on titaniums. And as I mentioned, the next one will be high temp alloys, so Inconel, wasp alloy, all the nastier things that you come across in the aerospace industry that require some careful methodology, and you kind of need to nail your tooling application as well for those materials. This webinar, along with his webinar, will be uploaded to our webinars link as well, so you'll be able to access them all. They're all on YouTube as well, and they're a great resource to just jump in. You know, you might have watched this webinar today, and then in a couple of weeks, someone say, "Oh, we need a spot drill, a micro spot drill," and you can say, "Oh yeah, we watched that SGS webinar not long ago. I can't remember the series of it," and you might just be able to say to your colleague, "Watch this. It's just an overview of what SGS has to offer." So these webinars, there's this one on high temp alloys. There's going to be another one later in the year on non-ferrous materials. And then as we move into 2022, there'll be other options again for different materials, maybe some composite ones, different materials. And and probably even our general purpose tools as well. So I just wanted to let you all know that these are available to view. They're available to review and download as well if you need to. So with that, I'd like to ask if there's any questions. This has gone a bit shorter than the last couple of webinars, but our micro tool range isn't as big as our general tool range. It's an addition to. There's not as much to share and show with you. But if anybody does have any questions, we'll open it up at the end of this. And if I don't have the answer right now, I am not a micro tools specialist. I am an applications engineer that has a wide range of experience in many different things. So if I don't know the answer, I can get hold of somebody that will, and I'll be able to get you an answer very quickly. So with that, I appreciate your time. Thank you very much. And if anybody does have any questions that they'd like to ask now, please feel free. If not, please feel free to email me. When this webinar gets uploaded, there'll be a link with my email address in there. So by all means, please feel free to contact me. And again, thank you very much.
Don't be afraid, guys. If anybody has any questions, please offer it up.
Hi, Andrew, Zania. Thanks for the great webinar.
Thank you.
Just a quick question. The micro tools, we come across ones in the mold and die industry quite a bit down here on our side. Sort of taper neck solutions. Has there been any discussion about looking at sort of taper neck micro tools to get into some weird and wonderful mold and die angles that we get into every now and again?
We do actually offer some tapered options already.
Okay.
There is they're generally ball end mills. They include a tapered end mills, but we do have some square cornered ones as well. They're not a massive part of our range. I'm just trying to actually find one in our catalog right now, but typically when I'm looking, I can't find the one I'm remembering. So for example, there's an M4 MB, which is a ball nose, and oh, there he is, an M4 XB. Sorry, didn't want to give you the other B, M2M. So there are options in there. If we don't have them as a standard catalog item, that doesn't mean we can't make them for you. We have specialist centers across the United States in both Virginia and Ohio that can make tools as what we consider specials. So there's definitely options in there, but if we do find that there's a demand for micro tapered end mills, that's something that we can definitely look at increasing in our range or portfolio in the coming weeks and months.
Okay, perfect. Thank you. Appreciate that.
I apologize if you can hear the horn beeping.
All right, guys, if no one else has any questions, I think it wouldn't be in keeping with the micro tool webinar if we didn't keep the time micro as well. So we'll say thank you to you guys for your attendance. We appreciate it. And we will be putting this, like Andy said, this will be on YouTube. This will be on our website. And this will also be promoted in our social media. So if you feel you know anyone that would have appreciated being here today, feel free to let them know where they can find the webinar today, and feel free to sign up for any ones we're going to be having in the future. Thanks, guys.
Thank you all very much. Really appreciate your time this morning.